Welcome to the deep dive. Today we're trying to cut through all the noise, really get to the heart of this ongoing battle. Fake news. And there's this, well, unexpected ally stepping up AI.
It really is unaccepted for some.
Yeah. Let's maybe kick off with a really vivid example, one that hit hard.
Okay.
So picture this. It's a Tuesday morning, May 2023. You're scrolling your feed, and suddenly, boom, there's this photo. Thick black smoke right next to the Pentagon.
Right, I remember this one. Sirens blaring in the posts alongside it.
Exactly. And before you can even, finish your coffee, the markets start dipping.
Just like that. Millions changing hands purely on reflex.
But here's the kicker, right?
Yep.
In less time than it probably took for that coffee to brew, officials were already out saying, nope, it's a fake, a deep fake.
A complete hoax.
Yeah. And that single moment, it just perfectly captured the danger, didn't it? How fast this stuff moves.
It's really astonishing how quickly a convincing lie can travel now. It literally outpaces first responders.
Forget human fact checkers.
Oh, absolutely. Way faster. That incident just made it painfully clear, that relying only on manual debunking, it's hopeless.
Just hopeless in today's world.
It's the sheer volume, the speed.
Mm.
We just need something smarter, something scalable, something that's kind of always watching.
And that, right there, is where the good news comes in.
Yeah.
Because AI is stepping up, and it's doing it with surprising finesse, actually. We're talking accuracy levels that felt like pure sci-fi just a few years back.
Yeah, the progress has been rapid.
Like, there was this paper, July 2025, in Scientific Reports. They unveiled a model hitting, get this, 99% accuracy.
99% on a benchmark data set, yeah.
By combining Google's BERT, the language engine, with graph neural networks. That 99%, it's not just impressive, it's a potential game changer.
It really is. But okay, for listeners trying to get a handle on this, what specifically about these hybrid models makes that kind of precision possible? What's the secret sauce there?
Right. So that's our mission for this deep dive. We want to unpack exactly how these, cutting-edge AI tools actually work.
Okay.
Why these hybrid methods are proving so effective. And maybe most importantly, point you towards some real-world products you can actually use today.
Tools to cut through the noise.
Exactly. To stay genuinely informed, we're here to help you navigate this pretty complex landscape.
Sounds good. Where do we start?
Okay, so let's first understand how these, sophisticated hoaxes manage to fool us so effectively. The sources we looked at highlight that they work on two levels, really.
Two levels, right.
First, there's the content itself, the text, the video, whatever it is.
Yeah.
It's usually crafted to push your emotional buttons, fear, anger, surprise.
Gets that initial reaction.
Exactly. But second, and this is key, the story spreads like wildfire, often through these tight clusters of like-minded accounts, creates a real echo chamber effect.
Right. Reinforcing the message within a specific group.
Yeah. And the early AI systems, they mostly just focus on the first part, scanning the content for things like clickbait phrases or suspicious keywords.
But that's not enough anymore.
Not even close.
Oh.
Because the really sophisticated hoaxes now, they can mimic legitimate writing styles almost perfectly.
But what they can't easily disguise, usually, is how they spread.
Ah, okay.
And this is where that idea of two streams are better than one comes in. It's fundamental to how the newest AI detection systems are built.
Two streams, got it.
So on one side, you have the language stream. This leverages models like, as you mentioned, Google's BERT.
Okay, but
BERT's a really powerful transformer model. It processes sentences, it picks up on context, sentiment, subtle linguistic cues, things humans might miss at scale.
you give an example?
Sure, like if you feed BERT a headline, something like, NASA confirms Earth will go dark for 6 days.
Classic fake news trope.
Exactly. BERT focuses on words like confirms, 6 days terms, often used in, fear-mongering posts. It flags that linguistic pattern, that sort of deep learning 101 for fake news detection.
Okay, so if BERT is so good at analyzing the text itself, why isn't that enough? Why not just rely on BERT? What's it missing?
That's a great question. BERT is excellent at understanding the content, the words on the page, right?
Right.
But it doesn't see the connections between the posts or the users sharing them. It doesn't see the network.
Ah, okay. It's missing the social context.
Precisely. And that's where the other stream comes in. Graph neural networks, GNNs.
GNNs. Okay, how do they work?
Well, think of it like this. Imagine every news item every user account, every share, every retweet as a little dot, a node in a giant interconnected graph.
Like a huge social network map.
Exactly. The GNNs learn patterns across these structures, these connections. They notice things BERT can't.
Such as?
Like, maybe an article's first 100 sharers were all brand new accounts. Created yesterday, 0 personal posts.
Big red flag.
Huge. Or maybe 90% of the accounts retweeting something also constantly spam a known disinformation hashtag.
Okay, so behavioral patterns.
Yes. Those propagation fingerprints, as some of the research calls them, they often scream fake much louder than the text itself. That's the machine learning approach applied to the social network aspect.
That makes a lot of sense. So the contents, the article itself, might look perfectly innocent.
Could be bland, even.
But the way it's spreading, who's spreading it, how quickly, that tells the real story.
Precisely. And the real magic, or maybe brilliance is a better word, happens in the fusion layer. It acts kind of like a referee between the two streams.
A referee. How so?
Well, when the model looks at a piece of content, the fusion layer basically asks, okay, based on everything, should I trust the language analysis from BERT more, or should I pay more attention to the network behavior from the GNN?
Interesting. So it weighs the evidence from both sides.
Exactly. For example, say it's a satirical article from, like, The Onion, and it suddenly gets shared organically by verified journalists who get the joke. Yeah. The network context looks legitimate, right? So the fusion layer says, okay, trust the text analysis here. It's likely satire.
But what if it's the opposite? A really blandly written post seems harmless,
Seems totally innocuous.
but it's suddenly being boosted like crazy by a network of accounts that look like bots.
Then the GNN signals dominate. The fusion layer says, whoa, red flag on the network side, and prioritizes that evidence. The system knows the spread pattern is suspicious, even if the text isn't.
It's like the authors of that 2025 paper put it, right? They said something like, we integrate BERT for deep textual representation and graph neural networks to model the propagation structure.
That sums it up perfectly.
That one sentence kind of condenses years of research, and it explains that 99% accuracy, not by magic, but just by really smart architecture.
And when we talk about that 99% accuracy, it's important to dig a little deeper than just that one number.
Right. Accuracy alone can sometimes be misleading.
Exactly. So the paper uses 5 key metrics. Accuracy, yes, but also precision, recall, F1 score, and AUC ROC. Basically, different ways of measuring how well the model performs and avoids mistakes.
And on the FakeNewsNet dataset, that benchmark, they used this dual-stream model, scored around 0.99 on all of them.
Pretty much perfect scores across the board in the lab.
Which is really remarkable because, just for context, models that only use language analysis, like just BERT, they usually topped out around, what, 0.93?
Yeah, low 90s.
And models that only looked at the social graph, the GNN part, they were maybe high 80s, 0.80s.
Correct. So this fusion approach, it didn't just close the gap, it leaped way beyond either method alone.
And importantly, precision stayed high, meaning it wasn't incorrectly flagging lots of legitimate news.
Right, minimizing the collateral damage to honest journalism.
And recall also stayed high, meaning the fake stuff had a much harder time slipping through, fewer places for trolls to hide.
But there's always a but, isn't there? A critical aspect here is connecting those shiny lab benchmarks to, well, the messy real world.
Ah, yes. Lab glory versus street performance.
Exactly. Fake news models often look amazing in controlled tests, but the real world throws curveballs. So when those same researchers ran that 2025 dual-stream model on a completely fresh set of data, 1.2 million tweets about COVID-19.
Okay, real-world, noisy data.
The F1 score slipped. It went from that pristine 0.98 on the benchmark down to 0.95.
Okay, 0.95 is still incredibly good. But that 3-point drop,
It matters.
it represents potentially thousands of borderline posts, maybe pandemic rumors, vaccine misinformation that might now slip by unflagged.
And those kinds of rumors, especially during a crisis like the pandemic, they mutate so fast, often faster than language models can keep up if they aren't retrained constantly.
So that slide, that drop, the real wake-up call, isn't it? Production systems, the ones actually deployed, they need constant tuning.
Constant vigilance, fresh data feeds, honest dashboards that track this kind of performance drift over time.
The lead author, Hejamati Ramamurthy, he put it really crisply. He said something like, the architecture delivers near-perfect precision in the lab, but no model stays static.
Yeah, we retrain weekly and still see novel misinformation patterns that test our assumptions.
That really lands hard. Fake news detection isn't some feature you just switch on and forget about.
No, it's a living service. It has to learn and adapt just as fast as the people spreading the misinformation pivot their tactics.
Think about CNN's in-house AI console they showed off in 2025 on the morning of that Pentagon smoke hoax.
The one we started with.
Yeah, their dashboard apparently lit up in under 90 seconds. The graph view showed this tight cluster, like 23 brand new accounts, all hammering the same image hash.
All originating from a single data center IP block, apparently.
Right. BERT, the language part, found nothing suspicious in the caption. It was just explosion near Pentagon. Very basic.
But the GNN.
The GNN screamed anomaly. Huge spike in coordinated activity from new accounts.
And because they had that hybrid detection, that combined view.
Editors saw the red spike. They apparently cross-checked with the Arlington Fire Department's official feed.
Which showed nothing.
And they made the call not to amplify the story. Now, markets still twitched, obviously.
But the tremor lasted minutes, not hours.
Exactly. If you want proof that this hybrid AI approach actually saves money, prevents panic in the real world, just look at the S&P chart from that day, tick by tick.
Yeah, the evidence is there. The lesson really is. Lab scores get you bragging rights, but field scores, real-world performance, that earns trust.
Yeah, so back to that CNN example. If the GNN screamed anomaly, did BERT find anything? Or was it just completely silent on that one?
That's a good clarifying question. In that specific case, because the text was so generic, explosion near Pentagon.
Not much for BERT to grab onto.
Right. BERT essentially found nothing alarming in the language itself. The entire signal, the key, was the GNN detecting that suspicious network activity.
Okay, so closing that last, say, 3-point gap in the F1 score, getting from 0.95 back towards 0.99 in the wild.
Yeah.
What does that take?
It means feeding the detectors more domain-specific data. If you're worried about election interference, feed it election jargon. Worried about health scares, feed it vaccine chatter.
Tailoring the training data.
Retraining often, maybe even daily during critical periods. And constantly stress testing against new adversarial samples, fake news, designed specifically to fool AI.
And it also means, presumably, making the AI less of a black box.
Absolutely. Wrapping the models with explainability layers. So editors, or even users, can see why the machine flags something.
Makes sense.
When the evidence pops up visually, like, look at this cluster of glowing red nodes all sharing the same link, instead of just an opaque probability score.
People trust it more. Journalists can act faster, with more confidence.
Exactly.
Okay, so this is all fascinating. The tech is clearly advancing fast. But what does this mean for you, the listener, right now? Groundbreaking research is great, but people want tools they can actually click, things they can use today.
Yeah, practical takeaways.
So we looked into some reputable tools out there, maybe grouped by who they're aimed at. For the big players, like publishers and newsrooms, there's stuff like Google fact-check tools.
Right, Google's offerings.
You can basically search a claim, like a headline you see, and it instantly pulls snippets from verified debunks published by fact-checking organizations. Google's AI here is surfacing human verdicts, not trying to make the call itself.
Which is a smart approach for trust. And CNN, as we mentioned, has its own internal dashboard doing that blend of language analysis, bot scoring, graph views, even video forensics.
Then for, say, medium-sized organizations, businesses, NGOs, there are services like Logically Facts Accelerate.
Logically, yeah, they handle a ton of languages, like 57 or something.
And they can ingest video, automatically generate potential claims from it, and rank them by urgency for human editors. Speeds up that triage process.
And then there are platforms like blackbird.ai. They offer these real-time war room maps showing coordinated inauthentic behavior.
Spotting those botnets or influence campaigns as they happen.
Highlighting clusters of accounts that are behaving just too much in sync. Really useful for crisis response teams during, say, an election or a public health event.
Okay, but what about for everyday folks? What can you use just sitting at your computer or on your phone? This is where it gets really exciting, I think.
Yeah, the accessibility is key.
You've got the Google Fact Check Explorer. Again, super simple, no login needed. Just paste a claim or keywords, see what fact checkers have said.
Really handy for a quick check.
Then there's the NVIDIA Weaverify browser plugin. This thing is like a Swiss Army knife for checking images and videos.
Reverse image search, right?
Yeah, reverse image search lets you go frame by frame through a video, pulls out metadata, all right there in your Chrome or Firefox browser.
Super useful for debunking those "is this photo real" moments.
Totally. Then there's NewsGuard. It's a browser extension. Put these little color-coded shields green, red, gray, next to links in search results and social media feeds.
Rates the general reliability of the news source itself.
Exactly. Now, it's definitely opinionated based on their journalistic criteria,
Yeah.
but they are very transparent about how they rate sites.
Transparency is good. What else?
The Logically app. Similar idea to their bigger service, but for individuals. You can paste in a tweet, a link, even a forwarded message from WhatsApp.
And it gives you a score.
Gives you an automatic credibility score, yeah. And often links to relevant human fact checks if they exist.
Nice.
And for the more technically curious, you can even play around with open source models on Hugging Face. They have these web demos, these widgets.
Right. You can paste text directly into a BERT or Roberta classifier.
Yeah. See how the AI analyzes it? Turns any web page into kind of a fake news detector playground.
That's cool for learning.
So all these tools together, they really show a major shift, don't they? A few years ago, this kind of advanced detection, it lived inside complex academic code, Python notebooks.
Only researchers had access.
Now in 2025, pretty much anyone with a web browser has a portable lie detector in their pocket or on their desktop.
That democratization of tools is huge. So maybe we should circle back to why these graph analysis models, the GNNs, are proving so crucial in this cat and mouse game.
Right. Why are they winning, so to speak?
Well, think about how misinformation thrives. It loves echo chambers, right?
Mm-hmm. Bounces around inside a filter bubble.
Bots often coordinate their actions like, I don't know, synchronized swimmers.
Yeah.
People forward posts sometimes faster than they even read them properly.
Guilty as charged, sometime.
We all do it. That whole chaotic network dynamic, that's exactly what graph analysis models are designed to understand and spot anomalies in.
So they're built to recognize the patterns of fakeness spreading.
Exactly. Twitter's own research, back when it was Twitter, showed that false tweets spread something like 70% farther and faster than true ones.
Wow. 70%.
And Facebook's big takedowns of state-backed troll farms, they almost always relied heavily on spotting those graph anomalies accounts created at the same time, sharing the same things, interacting in unnatural ways. Graph neural networks essentially turn those kinds of observations, those red flags, into automated filters.
So you could picture an AI just watching these retweet trees, these share patterns, forming in real time.
Mm-hmm.
And as soon as it sees, say, 15 brand new accounts, all created within an hour, all pumping the exact same dodgy link within 90 seconds.
The system flags that linked instantly for review, or maybe even throttles its reach automatically.
But that's not censorship necessarily. It's pattern recognition based on suspicious behavior.
Precisely. And remember that dual-stream model. It's designed to give high importance, high salience to those graph features in exactly these kinds of cases.
So it kicks in hard even if the text itself looks mild or harmless.
Right. This network-centric approach also has another advantage. It can catch cross-platform campaigns.
Ah, interesting. How?
Well, imagine a disinformation video first appears on some fringe Telegram channel, then it pops up on TikTok, maybe slightly edited, but using identical hashtags. Then it jumps to mainstream Instagram accounts.
A language model, looking at each post in isolation, might miss the connection.
Exactly. It sees separate posts. But the graph view, it can reveal the entire relay race. It sees the coordinated spread across platforms.
That's powerful.
Yeah.
But with such powerful tools comes great responsibility, right? We have to talk about the ethical side of this.
Absolutely crucial. False positives are a huge issue. If the AI constantly flags legitimate stuff as fake,
people stop trusting it. It erodes credibility fast.
So transparency really, really matters. Users, whether they're editors or the public, should ideally always know why something got flagged. What was the evidence?
And there needs to be a clear way to appeal, right, if you think the AI got it wrong.
Definitely. The authors of that scientific reports paper, they were honest about this. They admitted their model sometimes mistakes genuine organic virality, like a feel-good story suddenly taking off for bot amplification.
Ouch. Friendly fire.
Yeah. They advocated for better credibility scoring systems to try and reduce that friendly fire.
Okay, what other ethical concerns? Privacy must be huge.
Oh, yeah. Graph analytics, by definition, rely on user interaction data. Who shared what, when, who liked what.
Platforms absolutely must anonymize that data heavily. Minimize what they log. Protect user privacy.
There's an intriguing alternative being explored, actually. Putting the AI fake news detector inside your device, like on your phone or computer.
The on-device AI.
Yeah. The model runs locally. It analyzes the posts you see, but it never phones home with your data. It just whispers a little credibility score or a warning right there beside the post, just for you.
That's a neat privacy-first idea. Then there's the C word. Censorship.
Always a concern, especially in places where governments might misuse fake news laws as a blunt hammer to silence dissent.
So how do we guard against that?
Openness is the best antidote, usually. Platforms using these tools need to publish model cards explaining how they work, release performance metrics, error rates,
Let people see under the hood?
encourage independent audits. Bias checks should be absolutely mandatory, looking for political bias, demographic bias, any kind of unfairness.
And finally, there's just the inevitable arms race, isn't there?
Always. The people creating fakes get better AI tools to generate more convincing text and images.
So the detectors have to get smarter to counter them.
And the cycle repeats. Things like digitally watermarking AI-generated content could help, strengthening authenticity metadata in files.
Verifiable origins.
That'll help too. But ultimately, nothing beats just constant iteration. Machine learning thrives on fresh data. The detectors have to keep updating just as fast as the fakers pivot their strategies.
So zooming out a bit.
Yeah.
What's next? What does tomorrow look like in this space?
Well, we'll definitely see more multimodal fusion. Models that don't just look at text or image or our video, but merge all of it.
Cross-examining everything at once.
Yeah, like checking if the speech transcript of a video clip actually matches the visual context, or analyzing the audio for signs of manipulation while also checking the provenance of the video frames.
Yeah, that's advanced.
Multilingual reach will improve too, closing the gap for languages that currently have fewer resources, probably thanks to transfer learning techniques.
Taking models trained on English and adapting them.
Right. We might also see reinforcement learning used, teaching detectors where to look first in a massive flood of information to be more efficient, cut analysis costs.
What about more sci-fi ideas?
Well, imagine blockchain provenance. Every legitimate news item gets cryptographically stamped at creation. Your browser could instantly verify its integrity.
Instant authenticity check.
Or maybe cross-platform coalitions of tech companies sharing digital fingerprints of known viral lies so they can starve them of reach across multiple networks simultaneously.
A sort of rapid response network for disinformation.
Could be. Or even personal truth assistance. Imagine AR glasses.
Augmented reality.
Yeah. Overlaying credibility hints right onto your view. You read a headline on a billboard or a screen on the subway.
And a little green check or red flag pops up in your lens.
Something like that. Look, elections, health crises, major world events, they will continue to stress test these systems relentlessly.
But every stress test also generates new data, new examples of what works and what doesn't.
And machine learning just gets stronger with more data.
You know, it really is a paradox we live in, isn't it? The same neural nets, the same AI tech that can write incredibly convincing forgeries.
Can also be trained to catch them.
That Pentagon deepfake we started with, it really showed us that lies can sprint at silicon speed now.
Frighteningly fast.
But this hybrid AI, the combination of language and network analysis, it's teaching us that truth can sprint too.
We can build faster defenses.
The tools are definitely still maturing. They're not perfect. But they are already good enough, as we saw, to potentially save markets millions in minutes. And maybe, just maybe, one day they'll be good enough to help safeguard elections too.
But the tech alone isn't the whole answer.
Right at all.
The next viral lie, it's probably warming up right now, somewhere on the internet. The real power, I think, lies not just in these sophisticated detectors, but in how we, the listeners, all of us, engage with information.
It takes a combination.
Yeah, a smarter network of AI detectors, yes, but also a more media-literate public, a healthy dose of skepticism from everyone.
Asking questions before sharing.
Exactly. With that combination, maybe we can trip that lie before it even properly learns to run. It really works best when machines and humans collaborate. The machine spots patterns at scale, things we'd miss.
And the human applies judgment, context, critical thinking.
Together, hopefully, they keep the information ecosystem a bit healthier.
So before we wrap up, just a quick reminder of some of those specific trusted tools we mentioned that you can check out. Google Fact Check Explorer, the Invid and Weaverify browser plugin, the Logically app, NewsGuard, those Hugging Face demos if you're curious, and blackbird.ai for the organizational level view.
Use them. Share them with friends and family. Help others learn how to use them.
That's really how we turn this powerful technology into more of a shield for truth, rather than just another sword for those fretting lies.
Well said.
Thanks for joining us for this deep dive.